Hello, my name is Victoria Orchard, and in coordination with the Geography and Environmental Studies program at the University of St. Thomas, I was able to produce this geospatial analysis of potential toxic hazards in Houston. So why Houston? Houston makes an interesting study area because of the fact that it is so close to sea level. A lack of zoning regulations has led to what is called paving the sponge, or in other words, the mass increase in impervious surfaces that don't help absorb floodwaters. Houston is home to 41 of the nation's most hazardous toxic waste sites. Harvey hit 13 of these sites. So the real question is, does the cost of preparedness outweigh the consequences of putting people at risk to the toxic and hazardous waste floating around in these floodwaters? There are two major problems presented with toxic flooding. First of all, the policy surrounding identification of a potentially hazardous toxic waste site is ineffective and poorly enforced. Often these companies can skate by under the radar without ever being made public. Second, when a site is identified as a potential risk, there is no framework to securing the site in preparation for natural disasters such as hurricanes and flooding, which can often affect the greater area around the sites. Current policy makes siting a hazardous waste facility an extensive process with a lot of red tape. Therefore, these companies find reason not to go through this process at all. But when entering into this process, a nationwide survey in 1987 found that 81 of the recently cited applications actually had a lot of mishaps. 31 were denied or withdrawn, so therefore too dangerous to the public or going to cause too much damage in the long run. 36 were still under review and had been under this process for years, making the extensive process even longer. 14 received operating permits. 6 of those actually never used them, whether they were caught up in judicial court or with other reasons. Another survey conducted in the same year found that 52% of proposed commercial facilities were rejected because of public opposition. This public opposition stems from three things, the first being threats to property value, second being odors and nuisances posed by the operation of these facilities, and the third and most important being the health and safety concerns raised by the risk of accidental releases of hazardous waste. Unfortunately, we know that as a consequence of climate change, we are expected to see storms become more dangerous due to sea level rise, a warmer atmosphere, and a warmer ocean. These risk management plan facilities, TSDs, and Superfund sites can intensify the damages inflicted by a natural disaster by spreading the toxic and hazardous waste throughout the floodwaters. These toxic and hazardous materials leach into surrounding floodwaters and soil and risk poisoning large numbers of people. There are over 1,100 active hazardous waste sites within FEMA-designated 100-year floodplains in the United States. Owners of properties within this 100-year floodplain can actually contest boundaries of the flood hazard boundary maps, putting themselves inside or outside of the floodplains. If we take a look at this map, we can see that the red indicates 100-year floodplains, whereas the orange indicates 500-year floodplains. The EPA does not prohibit the operation of facilities in either of these floodplains because of two things. The first being potential economic impacts of such a requirement, and the second being a lack of availability of techniques to protect facilities from the harm when a natural disaster does occur. When looking at this issue as a whole, I decided to focus on where people were most vulnerable in the face of a natural disaster such as flooding. In order to determine where people were most vulnerable, I looked at vulnerability in terms of three things. The first being potentially toxic and hazardous waste sites, the second being vulnerability in terms of water, and the third being vulnerability in the terms of demographics. By combining these three measures of vulnerability, I located areas of interest for future conservation efforts. This is the model I created to outline my research. By dividing this model into three parts, it becomes easier to see why Houston is so unique in its flood challenges. First, we are going to take a look at vulnerability in terms of potentially toxic and hazardous waste sites. This is the top portion of the model. For this portion of the model, I combined three different types of toxic and hazardous waste sites: Superfund sites, hazardous waste management sites, and potential chemical accident sites. When looking at all three maps together, you can easily identify hotspots in Houston's city center and near the coast. By combining these three maps, I produced a map depicting where people are the most vulnerable to all three of these types of sites. This area is shown in red. Next, I'll focus on the middle section of my model, which looks at vulnerability in terms of water. By combining tools for Euclidean distance from water and the digital elevation model, I was able to isolate areas that are close to water and near sea level. These areas are depicted in blue. Last, I'll focus on the third portion of my model, which examines demographic vulnerability. In order to determine demographic vulnerability, I used three features: low income, minorities, and people with less than a high school education. The dark red areas of this map are the most demographically vulnerable people in Houston. Looking back at the model as a whole, I combined three portions to identify an area for conservation focus. This conservation focus map shows areas from which people are extremely vulnerable in the face of natural disaster. Once again, we can see that the city center and coastal areas are of major concern. It's important to look at the role demographics plays within this model. If we look at the darker blue color where people are vulnerable to flooding, it's clear that demographics vary greatly. But when it comes to hazard vulnerability, those who are of low income, minorities, and have less than a high school education are much more likely to be nearby a toxic or hazardous waste site. Moving forward, efforts to better control the flooding of these toxic and hazardous waste sites need to consider that many factors contribute to the amount of damage caused by the release of materials into floodwaters. These factors include but are not limited to the depth of the floodwater, velocity of the floodwater, duration of time that the water is stagnant, and the total fall of water on the land. Many of these factors are actually magnified by climate change. There are ways in which we can greatly reduce, if not prevent, the risk posed by these toxic and hazardous waste sites. These preventative measures must take place before the natural disaster in order to eliminate risk, but include putting tarps over waste pits, cleaning and removing contaminated equipment, shoring up petroleum tanks, and building barriers around the areas. In the future, I think it would be interesting to do further research on how climate change will affect the damage inflicted by these sites in the face of a natural disaster. The need for anticipating climatic change when making flood maps and regulations is imperative. FEMA and other organizations involved with floods and natural disasters need to complete better and more in-depth research in order to tackle the risk posed by these facilities. Finally, I would like to highlight the sources that made this presentation possible.